Today the topic is speed-time graphs. The prior knowledge required before you start solving these questions. For any speed-time graph, the distance traveled is given by the area under this curve. So if you want to find these areas, you should know the formula for the area of a triangle, which is half base times height, or you can say VH over 2, it's the same thing. The area of a rectangle, which is L times the length times width, and you should be knowing the area of a trapezium. The trapezium has a pair of parallel sides, and the distance, the perpendicular distance between these two sides is taken as the height h, and let A and B be the length of these two parallel sides. Then the area is given by half times height multiplied by the sum of the length of the parallel sides. Or you can even write it as h over 2 times A plus B. You should also remember the gradient formula at times that can be used, which is gradient m, or the slope of the line, is equal to y2 minus y1 over x2 minus x1. Now the gradient, if you want to find the acceleration between these points A and B, it is given by the gradient. So to find the acceleration, it is enough to find the gradient using the gradient formula. Question 1, the diagram shows the speed time graph for the first t seconds of a car journey. Find the acceleration during the first 10 seconds. So the first 10 seconds, here is the time, and they have asked for the acceleration. So we know if it is the acceleration that you want from this point to this point, which is the first 10 seconds, you have to find the gradient. So here m is just the change in y over the change in x. So the change in y here is from 0 to 12, so it's a 12, over the change in x is 0 to 10, it's a 10. So the gradient is 1.2. So your answer for the acceleration here is equal to 1.2 meter per second square. You can see the speed is in meter per second and the time in seconds, so the acceleration is meter per second square. Now for those who are comfortable using this formula and they don't want to do it this way, you have the coordinates here 0, 0, and here it's going to be 10, 12. So you can just mark the coordinates and write x1, y1, x2, y2, and if you just apply it here, you can see 12 minus 0 over 10 minus 0, which is again giving you a 12 over 10. You can do it either way. Now, second part of the question, the total distance traveled during the t seconds is 480 meter. Find the value of t. So they have a total journey which has taken t seconds. So can you see this t here? And they have said that the distance traveled is 480 meter. Now, as said earlier, the total distance traveled is nothing but the area under the curve. If you look into this graph, what you see is a trapezium. So you're going to use the area under this trapezium equated to 480 meters, which is the total distance. So let me just draw it here. From 0 to t, so this side is t, the top part, now these are the parallel sides of the trapezium. Now this distance is going to be t minus 10, so this is t minus 10. Why? Because the line from here to here is t, so we just want to start from here. So this part, this is going to be t minus 10, and the height is 12. H is going to be 12. You can get it from the y-axis. This is the height. So the area of a trapezium is h over 2 times a plus b, which is equal to 480, the total distance traveled. Now substituting the values, 12 over 2 times your a is t minus 10 plus you have a t here. So I have taken this as my a and this is my b. Substituting it and equal to 480. Simplifying it further, 6. I have 12 divided by 2, which is 6. And within brackets, I have t plus t. So 2t minus 10 is equal to 480. You can expand it if you want, or you can just divide 480 by 6 and then simplify further. So I'm just expanding it here. I have 12t minus 60 equals 480. So 12t is going to be 480 plus 60, which is going to be 540. So my 12t is 12t is equal to 540, and t is nothing but 540 divided by 12, and the answer is 45. So your value for t is 45 seconds. Question 2. A car starts from rest and accelerates for u seconds until it reaches a speed of 10 meters per second. The car then travels at 10 meters per second for 2u seconds. The diagram shows the speed time graph for this journey. The distance traveled by the car in the first 3u seconds is 125 meters. Find the value of u. And you have to find the acceleration in the first u seconds. So you can see in the speed time graph, they have not mentioned any numerical values along the x-axis. It's just u and 3u. So the first part of the question is to find the value for u. Now here 125 meter is the total distance traveled, which can be given by the area under this curve. So what am I going to do is to identify the shape. Now these are the paddle sides. If you look at this length, it's going to be 3u minus u. So 3u minus u giving you a 2u. So this will be your A, and your B is equal to 3u. And the height h is given by, from the y-axis we can see it's equal to 10. Applying the formula, h over 2 times a plus b is equal to 125, which is the total distance traveled in the total time 3u seconds. So substituting, I have 10 over 2, which is my height, over 2 times my a here is 2u plus my b is 3u, and this is equal to 125. So I have 5, 10 divided by 2 is 5. 5 multiplied by, what is 2u plus 3u, giving me a 5u, is equal to 125. So 25u is equal to 125, from which u is going to be 125 divided by 25, giving me 5. So your answer, the value of u is equal to 5. Now the next part of the question is to find the acceleration. We know if it's the acceleration, we have to find the gradient of the line, which is in the first u seconds. So u is here, so the acceleration between these 2 points, which is, now u is already 5, which is calculated, so you have 5 and 10. So the gradient is equal, change in y over change in x. So change in y is 10 over the change in x. Now u is already 5, so 5, which gives you the answer 2. So your acceleration is going to be 2 meter per second square. Question 3. A train journey takes 1 hour. The diagram shows the speed time graph of this journey. Calculate the total distance of the journey. Give your answer in kilometers. Part B. Convert 3 kilometers per minute into meter per second. And calculate the acceleration of the train during the first 4 minutes. Give your answer in meter per second square. So you can see that you can have some unit conversions coming into this question. So let's start with the first part, calculating the total distance of the journey. Now in this question, I will try to split this whole, though it's a trapezium and you can directly apply the formula which we used in the previous questions. I would like to give you one more method for those students if you just forget the formula of the trapezium. You can just split the whole area here into A, B and C, which denotes 3 different shapes here. Can you see you have a triangle, a rectangle and a triangle. So let me just draw it separately here. So this has a base 4 and a height 3. So this is my triangle A, and plus I have a rectangle which has a length here. This is 50 and 4, so I'll do 50 minus 4, which is 46, and the height is again 3. So this is my rectangle, which is my second shape, and moving on to the last triangle, which is if you check here, it's 60 minus 50, so it's a 10, which is the base, and the height is again 3. So let me apply the formula. For the triangle, it's BH over 2, so it's 4 times 3 over 2, plus, I'm just calculating the area here, 46 times 3, plus I have another 3 times 10 over 2, which is equal to 6 plus 138 plus 15. So the area is going to be a total of 159 kilometers. Moving on to 3b, convert 3 kilometers per minute to meter per second. So 3 kilometers per minute need to be changed to meter per second. Now just in case if you have forgotten the conversion, now from kilometer to meter it's 1,000, and from minutes to seconds it is a 60. So you can see 1 kilometer per minute is going to be equal to 1,000 over 60 meter per second. You can simplify it. So you can convert 3 kilometer per minute to meter per second by multiplying 3 with 1,000 over 60. So when you simplify it further, your answer looks like 50 meter per second. So that's the answer for part BI. Moving to part BII. Calculate the acceleration of the train during the first 4 minutes. So acceleration here, the first 4 minutes is going to be the gradient, and the gradient formula is change in y over change in x. So here it's 3 over 4, which is the change in x, and the unit is kilometer per minute squared. So this is the acceleration. Now the answer doesn't end there. You want the answer in meter per second square. Okay, again, 1 kilometer per minute squared. Let me just change it to meter per second square. So 1 kilometer to meter would be 1,000, meters over minute square. So 1 minute is 60 and it is minute squared, so 60 times 60, or you can write 60 squared. So that is the conversion. So in this case 3 by 4 kilometer per minute square is equal to 3 by 4 times 1000 over 3600, 60 times 60 meter per second square, which is equal to 0.208 meter per second square. The diagram shows the speed time graph for 120 seconds of a car journey. Calculate the deceleration of the car during the first 20 seconds. Part B, calculate the total distance traveled by the car during the 120 seconds. And calculate the average speed for this 120 second journey. So starting with part A, calculate the deceleration of the car during the first 20 seconds. So here you have the 20 seconds and you can see it's a straight line. So deceleration is nothing but a negative acceleration. So here again you find the gradient is equal to the change in y. Here the gradient is going to be negative. So now regarding the sign of the answer, if you're talking about an acceleration, your acceleration here is going to be negative. So since it is, they're talking about the word deceleration, which is already negative acceleration, you just find the change in y. So from 10 to 18. So 18 minus 10, you have 8 over, this is going to be 20, which is equal to 0.4 meter per second square. Now again, let me remind you, if the question was to calculate the acceleration, it will be a negative 0.4 meter per second square, but since it is deceleration, it's just 0.4. Part B, calculate the total distance traveled by the car during the 120 seconds. So here you have 120, so they're going to ask you to find the distance traveled, which is given by the area under the curve. So first let me split this because it doesn't have a complete formula that can be applied. So I will split this into a rectangle. I have a rectangle here, A. I have two triangles, so let this be B and C. You can divide it in your own way, whether you want two trapeziums here and a rectangle in the middle, it's up to you. My rectangle is A, which has a length of 120 and a height of a width of 10. Plus I have a triangle B, which has a base of 20 and a height here is 18 minus 10, giving me 8. Plus I have my triangle C, which has a base. So this is the distance which I want. So I will take it as 120 minus 90, which is a 30. And the height here is this is 10 and you have 20, so 20 minus 10 giving you a 10. So the area here is going to be 120 times 10 plus 20 times 8 divided by 2 plus 30 times 10 divided by 2. So it's going to be 1200 plus 80 plus 150. Which is equal to 1430 meter. So this is the answer for part B. The total distance traveled is 1430 meter. Moving to the last part of the question, calculate the average speed for this 120 second journey. Average speed is equal to total distance divided by the total time. So here the total distance was 1430 divided by the total time taken was 120 seconds, giving me the average speed as 11.9 meter per second. So that's it for the day.